Now for the last part of this question, which is worth 3 marks, we're told that we've got another point B that lies on this curve C. And the tangent at B is parallel to the tangent at A. And we've got to find the x-coordinate of this point B. So in the previous part, remember, we had our point A at -5, -16, and we found the equation of the tangent. That equation of the tangent, do you remember, was y equals 20x plus 84. Okay? So where's the point B going to be? Where's it likely to be? Well, looking at this sketch, I would think that it's going to be somewhere up here. Let's just put the point B about there, okay? So in other words, we've got a tangent at B which is going to have the same steepness. It's going to be parallel to the one at A. So that's basically the clue to how we start to solve this. We know that if it's parallel, it's going to have the same gradient. So already then we know that the gradient value for this line, m in other words, has got to be 20. But the point is, how do we relate this 20 to the curve? Well, we know that dy by dx at any point on this curve gives us the gradient, and we found out dy by dx earlier. Do you remember we found out that dy by dx, this was done in the second part of the question, dy dx equaled 3x squared plus 14x plus 15. So what we can say is if we set this gradient equal to 20, we'll be able to solve it for x, and it will give us the x coordinate at B. Mind you, it will give us also an x coordinate at A, because that too has a gradient of 20. So let's just say that at B, okay, dy by dx equals 20. So we can say that therefore 3x squared plus 14, that should be 14x actually, let's just put that in as 14x, plus 15 equals 20. Now we've got a quadratic equation here, so we need to remove the 20, subtract 20 from both sides, so it equals 0. So we get 3x squared plus 14x, and 15 take away 20 is minus 5, and that equals 0. And we can factorize this. A couple of brackets equals 0. It's going to be a 3x and an x to give us 3x squared, and then just by looking at it I can see that a minus 1's got to be there and a plus 5's got to be there. You can check it out. 3x squared, then you got 15x minus 1x, that's 14x, and minus 1 times 5 is minus 5. Okay, so when you have your quadratic then equal to 0, the two factors, each of these factors can equal 0, so we can say that therefore 3x minus 1 equals 0, or we've got x plus 5 equals 0. So if we add 1 to both sides, we get 3x equals 1, and then divide by 3, you end up with x equaling a third. And for this one, if we subtract 5 from both sides, we get x equals minus 5. Now, these are the two x values then where the gradient on the curve is 20. But you can see that x is minus 5 corresponds to the point A. So x equals third must correspond to the x coordinate at B. So that's our solution. So we can say that therefore the x coordinate, just to finish off the question rather than just leaving it loose like that, the x coordinate at B is 1/3. Alright?